Hello there and welcome to this course on handling missing data for healthcare with Python. My name is Valentine and I'll be your instructor. In this course, we are going to follow this structure. We'll get started learning about the learning outcomes. After that, we'll get to learn about what handling missing data for healthcare with Python entails. We'll get to learn about also reasons why we handle missing data in healthcare. After that, we'll now go into our practice session that will entail undertaking different techniques that will allow us to be able to take care of missing data within healthcare data sets. In that particular section of practice, we'll get to go through different concepts as well as just examples that will allow us to acquire that skill pertaining to all the different concepts. And then we'll also provide you with exercises that will also allow you to just put into practice. Then towards the very end, we'll just talk about the next step. So this workshop generally is more of a beginner workshop when it comes to handling missing data. If you are a beginner, but not a complete beginner, maybe you have worked with Python before with regards to maybe just understanding the Python fundamentals, like, for example, how to work with variables, arithmetic operators, loops, lists, dictionaries. If you have that kind of knowledge from before, then this workshop or this course is suitable for you. But if you are starting from the beginning, we would highly recommend that you consider going through a Python fundamentals workshop or course. Then it doesn't really have to be in healthcare, though we do have a workshop still that we've done before in healthcare. Before now going through this workshop. You could also decide to go through a workshop on data wrangling. That would also enable you to be fully prepared when it comes to just working with data sets. Our focus won't be on importing data. Our focus in this workshop will just generally be on handling missing values. So let's get started. By the end of today, we expected to have achieved these learning outcomes. We should be able to explain the impact of missing data on healthcare analysis. We should also be able to apply data cleaning techniques to handle missing data in Python. That means being able to implement various data imputation methods to fill in missing values in generally data sets, healthcare data sets. So starting off, handling missing data in healthcare with Python generally just involves performing cleaning techniques related to data pre-processing, statistics, and machine learning, and with an effort to deal with data sets, healthcare data sets that have incomplete or missing values. And the reason why we would perform these particular techniques would be because if we use data sets that have missing values, we could end up getting biased results or even just incorrect conclusions. For example, you could have a data set that has missing values for the age column, and you might not be able to answer research questions such as what was the average age of the patients within your institution. So in such a situation, if you have missing values within the data set that you're using to rely on answering that research question, then you would eventually end up getting incorrect conclusions. So the processes or the techniques that we're going to learn will help us understand how better to resolve those inconsistencies that or missing incompleteness aspects that we have within data sets. So we'll get to learn a whole lot about them. However, just it's also important to note that missing data in healthcare data sets can arise as a result of many reasons, some of which include sometimes there could be incomplete patient records for reasons that maybe there were data entry errors, or the system that was supposed to pick that data did not provide the mandatory option for filling in the respective field for the data set that you're working with. In some other situations, yes, there are data entry errors. Human beings can make mistakes when they are inputting data, and errors can arise. Some other situations, patients might decide not to give data because they don't think you need to learn a whole lot about them. They just want you to, or the organization or the hospital, to just treat them without necessarily considering some data that they might consider maybe personal or irrelevant. Some other situations, maybe in terms of technology issues, you might have during maybe a data migration aspect. Maybe if a hospital or a healthcare institution was migrating from one system to another, some data might be lost in that process. And in such a situation, then missing data can arise. In other situation, privacy concerns, again, still in the case of patients not wanting to give information because of just privacy concerns. They might give you just a little bit of some information, but not all. And in such a situation, you end up getting just missing data that may not necessarily help you to answer research problems that you are looking towards answering, maybe as a healthcare data analyst or healthcare data scientist or someone who deals with data within a healthcare institution. So when it comes to just why would we then handle missing data? There are various reasons. I think we've already talked about the first one, which would be that missing data within data sets can lead to inaccurate conclusions if there are just missing data within the data sets that you're using to answer the research problem. It could be also one of the outcomes of having missing data that you can end up making maybe patient care decisions that are not well supported by data, or they might be not the best patient care decisions that you might end up making if you rely on, again, data sets that are inconsistent, data sets that don't have missing, that have missing values. In other situations, missing data can compromise the validity and reliability of maybe study findings. Maybe if you're a researcher within a healthcare institution, if you have missing data, then the findings may not be really reflective of the population that you're studying. Healthcare organizations are also subject to regulations and standards, maybe regarding data collection, storage, and reporting. Might be that within a particular jurisdiction, if you do not have sufficient information about a patient, then you need maybe to ensure that you have that information. Like you can't just have just partial information of data or patient data, because that could misinform maybe healthcare stakeholders who might end up interacting with that data. So in such situations, yes, you could handle missing, you would be opted to handle missing data. And again, in other situations, still as a result of decisions made using data sets that are inconsistent, missing data can pose risks to patient safety and also the quality of care. So we've talked about just what, we've talked generally about the techniques that we're going to cover, but what are they? Still from a general perspective, the techniques that we are going to be working towards, even though these are general, there will be specific techniques for each and every category of the techniques that we have displayed. Finding missing data, we'll get to see how we can be able to find missing data within data sets. Also get to know within the data set that we are working, which columns and how many values do those columns have in terms of missing values. We will get to learn about how to drop missing data with regards to records if in situations where the the resulting data set after dropping the records that have missing data does not significantly impact our findings, then that can also be a suitable solution. Not only are we going to learn how to drop just records, we're also going to learn about how to drop columns. By dropping, it means just deleting. We're also going to learn how to replace missing values, just in case you might have some domain expertise in what makes sense for what is missing within a data set. So we'll come up with some arbitrary values that we can be able to assign to just missing values. In other situations, we might also want to perform mean, median, or mode imputation. So for those columns that have missing values, we might decide to use, let's say, the mean of, let's say, a numerical column to fill in those numerical missing values within the data set. The same case with also, if we want to now get far much more accurate missing values, far much more accurate values that are representative of the missing values, then we can also implement machine learning techniques, which we are going also to get to learn how to do that. So those are the techniques, but under each and every technique, there will be just different categories for different techniques under each and every categories that we can be able to use. So yeah, at this particular point, I am going to ask you to visit the resource link that we've shared on the video. Just below the video, there's a resource link. Click on that link and it should take you to a page that looks like this. So this will contain the sample practice resource that you see linked here. So in this resource will look like this. It will be just a notebook, which is a document that's data analysts or data scientists use to be able to share work with other stakeholders. So we'll be using this notebook to go through our workshop and go through those techniques practically. For those who are Afterwork members, if you want to practice extensively, you could just simply decide to become an Afterwork member, get started, and then you can get extensive practice work, because the sample notebook only has just a few challenges, but for the practice notebook, for each and every concept we learn, there will be a challenge, and there's also going to be a solution notebook that will provide just a solution to say the actual challenge that will be covered. So again, if you want to practice extensively, you could always consider becoming an Afterwork member and getting the resources that we're going to be going through, and it also supports our work and helps us continue doing what we do. So yeah, so let's now open that notebook. Once we get to this notebook, the first thing that we will need to do is to save a copy in Drive. So we go to File, then save a copy of this notebook in Drive. So File, then save a copy in Drive. And the idea is that you're going to save a copy that you can be able to make changes to and save those changes maybe for future references when you want to maybe make some changes or something. So once you have done that, it will open, that new copy will open in a new tab. You can close the old one, and you can rename it however you want by clicking at the very top and just changing the name. So yeah, so also something else to note is that if you feel like we are too fast in this workshop or this course, you can always just pause the video or rewind, or just go back a bit and just go through the steps that we've taken. So yeah, so like for example, for saving a copy in Drive, if you feel like you've missed something, you could always go back. That's the beauty of streaming as opposed to just having live workshops. So yeah, so let's do that. Once you're done, once you've saved a copy in Drive, the next thing we need to do is to connect our notebook to Google servers, which are going to be running the Python code that will be contained within this notebook. So we need to click on the connect to a new runtime button. So click on that. It will take a few seconds, and then we should be good to go. We can opt to work with this notebook locally, but the process of just installing and troubleshooting just the required software for that may be a bit more lengthy, and that's not what we're really focused on when it comes to the learning outcomes. So once you've done that, the next thing that we now need to do is to now go through each and every concept. So we'll start off with missing data. By the way, in a notebook, there are usually cells. There's a text cell and a code cell. Code cell looks more like, if I click here, it looks more like this, and we can put code in here. So, but that's not really so much of our focus. So let's just giving you just an idea for persons who are just new. But if you're not new, which that's the idea, then we should be good to go. But if you're new, just bear with us, or you can just go through what we're doing and go back again to another course and go through that as well. So finding missing data, so we can now go through the first one. We will import pandas, which is a library for performing data manipulation. By the way, if you get this pop-up, it means that your notebook was not saved in a drive. So that's what I'm going to do with mine. So I'm not actually going to save it in drive. What I'm going to do is to go to open in playground mode, and you don't need to do this. I'm doing this because I don't want to make any changes to my my notebook. But saving a copy in drive, like what you did, is sufficient enough. And once you've connected, then we can continue. So where did I leave you? I left you here while you're importing the pandas library for manipulation. Just run anyway. But if you've saved a copy in drive, you won't see that pop up. So once we have done that, let's now go through this concept. How do we find missing values within a data set? So first of all, we are going to, as you can see, by the way, we have just some explanation for each and every concept and a challenge. So once you've gone through the examples, you can pause the video and work on the challenge afterwards. So starting off, we can decide to read this data set and then check for missing values. So we read this data set that's in this URL and store it in the df data frame. And then we apply the isNull function to the df data frame, and also the sum function to the result of that, and that will give us just the missing values. So if we run this, we should be able to get missing values. As you can see, we have age, income, education, and age, income, and education. Those have just missing values, as you can see here. So yeah, so that's generally how you check for missing values within data frames. Not something hard. It tells you that age and income and education have missing values, and in age there's 1, in income there's 3, in education there's 1. Please take note that you can still further explore the data set the way you want. Like you can decide to do let me just open a new code cell, df.head, or just print out the entire data frame. And that should give you it can give you just a good perspective of where those missing values are. Like you can see here, there's a missing value. NaN is a missing value. We also have a missing value here, and also another missing value here. So, and also there's also another one here. So you can do this visually, but it's not the most efficient way. But this is also this is the best way to just identify the missing values. So note this, we are going to be using this approach a lot. I won't be explaining it further. Just note that this code will be using it a lot to just check for missing values before, when we are working with a data set, and even after we have performed after we have handled the missing values, to just confirm whether the missing values have been handled. Right, at this particular point, pause the video, work on this challenge, and then we can continue. Just pause the video, work on it. If you're an Afterwork member, you could always just go to the solution once you've finished and verify your solution. Just pause the video and then we can continue afterwards. Awesome. So once you have gone through finding missing values, now missing data, so the next section we are going to go through is dropping missing data. So here we're going to learn about two concepts. So we're going to learn about how to drop records that have missing values. And you might want to perform this operation if you realize maybe the number of records that you're going to be dropping are quite small. Those records do not significantly impact the final outcome or the analysis. So for example, if you have 100 records and maybe just one record has missing values, you could decide to drop the or delete the record because there won't be any significant difference noted. So that is something that you could do. But if you have maybe 50 records that have missing values, then it means that you need now to think about other ways of just handling the missing data, whether it's just going back again to data collection and looking for the respondents data again, then that could also be another option. So let's learn how to drop records with missing values. So here we are going to read the data set just like we did in the first section. We're just going to load the data set and check for missing values. And we can see diagnosis has one missing value, and we can decide now to drop the record with just the missing value by using the drop NA function. So we apply it to the DF data frame, and we specify that we want to drop records with any missing values. And we can decide also to just say in place, we can also put this as, we can set in place to be true to apply the change that happens here to the original data frame. You may not necessarily need to put this one as well here, how any. Sometimes you might want just to show what happens behind the scenes, but you could also run it as shown. So yeah, so I can even just run it as shown, and you should be able to see that we have just a diagnosis has been taken care of. So we don't have missing records in the new data frame, which is DF. At this particular point, pause the video, work on the challenge, and then once you're done, we can continue. Dropping columns with any missing values. So sometimes instead of working now with rows or records, we might want to just drop now the columns instead. So let's first of all load this new data set. Again, by the way, we have so many data sets, just to give you just different scenarios and real life, variation of just the data sets that you might end up working with. So please bear with us if there are too many. Yeah, so we have this data set, we load it in DF, we check for missing values. We have age has missing value, weight and height has missing value, as well as blood pressure. So we can decide to drop the columns with missing values by specifying the axis. The axis parameter here it's 1. We specify that we want to work with the columns. In place, I think we are already familiar with that. To just apply the change, the operation here to the original data frame. So, so something to note is that here we're specifying it as 1, but by default it's usually 0, but we don't define it. When we say axis is 0, we're actually referring to the records, but here we specify it to 1. So we are going to be dropping the columns that have missing values, and then we check. You'll see that there are reduced number of columns. We have ID, name, and gender. So ID, name, and gender, because these are the columns have missing values. All right, so we've covered a bit. Pause the video for those who are Afterwork members, and then work on the challenge, and then we can continue. By the way, if you again would want an Afterwork member, just gets access to all the resources that we have on our platform, which we could get projects, you can also get certifications. So you could always consider doing that, and it will actually feel easier for you when you're going through these workshops. They will just feel like, okay, you're practicing and learning something. All right, replacing missing values. This is the other concept. These are 3 different concepts. So under replacing missing values, we have arbitrary value imputation. So this refers to that concept of replacing the missing value with maybe a constant or a realistic value that we have based on our domain expertise. So that's what we can do. There's forward field replacement, which tends to take the previous missing values value. So if we have age 100 records with age with also, and in one of those in those columns, in those records, we have a column called age, and maybe record 51 has a missing value of age, but record 50 has an age value. So we can forward fill. So we take the record, the value for age for record 50, and we fill it as what we would want for record 51. So backward fill replacement actually takes the one that's next, let's say 52, and fills it back. So yeah, so let's learn how to do that. So arbitrary value imputation, we would choose this particular technique if we have some domain expertise, or we just also want to maybe represent missing values with just one particular constant, maybe double zeros or triple zeros or x's or something of that sort. Yeah, so we can always do that. So let's check for missing values in this data set. We have one in underpin pressure. Then we can replace the blood pressure one, missing value, with just a 0. So we specify that we want to do that, and we use the fill NA function to do that. And we can see that blood pressure here has already 0. So it means in blood pressure, we don't have any missing values. But you could always, again, confirm using, let's say, by printing out the entire data frame, but it may not be realistic if you're dealing with a larger data set. All right, pause the video, work on this challenge, and then once you're done, we can continue to the next one. Forward fill replacement. So we can use this method to replace missing values with the last known value in that column. So for example, in our case, let's run this. We have age, we have income and education. By the way, we normally do this maybe if we are working, we use this concept maybe if you're working on if you are working with time series data, which sometimes data may not be significantly different from other previous values. So in such situations, one could use this. But again, you could always, towards the very end of your analysis, understand, do some further analysis to understand the impact of your missing value on the entire data set, because sometimes you don't want to introduce a missing value that significantly changes maybe the distribution of the data set, and because one value should not do that. Should be like many values should be able to do that. So yeah, so let's apply this method, forward fill replacement. We use ffill. We define, we set that as the value for method inside the fill NA function, and then we run that. We can see that we now don't have any missing values. At this particular point, pause the video, work on the challenge. Then once you're done, we can continue. Backward fill replacement, we can get to work with this technique. It's almost like forward fill, but now it takes now the next value within the next record and uses it for the missing value. Again, could also want to use this maybe if it's maybe you're working with a time series data set. It might be helpful in such a situation. So let's run this. We have end date. We could decide to fill in that, so we can use bfill. So instead of using ffill like we used here, we use bfill. Awesome. So pause the video once you're done, then we can continue to the next step. Sometimes you might want to work with a value that is representative as a result, or a representative of the missing value as a result of maybe the other records values. So maybe perform the mean of the existing values for a column and use that as the mean value. So we can use mean imputation to handle missing data also, and yeah. So let's work with this. By the way, this method also helps in ensuring that we still maintain the overall distribution of the data. So it also helps us prevent bias that can result from a new value that is significantly different from the rest of the values within the data set. So let's load this data. And then we're going to use what is called simple imputer, which is what we have here. So we can even just run this. You might get an error if you skip this, by the way, when you try to run here. So the simple imputer is a class that allows us to just work with just different strategies for imputing. So we mentioned that we want to use the mean. So inside the object where we are creating, this is a class that we have imported. So we create an object in this line, but we define that we want to have strategy as the mean. And we now apply this imputer, which is the object, to fill missing values in the age column as shown here. And then we replace that, the original value of age, values of age that are missing. And then we check for missing values. You can also use another alternative, another manual or alternative where you calculate the mean separately, and then you use the fill, the arbitrary value imputation, like here. Instead of 0, you could decide to calculate the value of mean separately, then fill it in using this method as well. But you could also use this other method too. We decided to just use this method because it also is, we're going to build it up also to learn how to implement other different imputation methods, especially for median and also mode. But you could also do the same thing for median too. All right, so here we have only done for age. You could also do for income. Let's see how that happens. But note also that this works with only numerical values. It doesn't work with categorical values. So if you have a variable that has maybe gender and has just categories like male, female, then this may not be the best one. The best method for such a situation would be mode imputation, which takes the most frequent value of that column, which in such a situation can be one particular class. All right, work on the challenge. By the way, you can pause the video and then we can continue after that. Median imputation. So we would use this method when we want to replace the missing values with a median value. And this approach would be normally useful, assuming that you've done maybe a study of your data set. Maybe you've tried to check the distribution of the data set. And you've noted that it's not normally distributed, then we can use this approach. So you could always check for that distribution by just having a histogram and understanding how or understanding whether it has a bell-shaped curve or not. That is something in statistics we cover also in another workshop. So yeah, so let's run this. We can see we have age and income missing, so we can just use a strategy as median. It's almost as close as we did here for mean. So here we're going to just change this to median and apply the imputer to fill in just the missing values in the age column, and then print it out. You can do that also for income. Yeah. So also something to note is that sometimes you might also work with some columns and you might get errors like, and maybe this string cannot be, you're applying maybe a certain numerical operation or mathematical operation to a string column or that has text values. So in such situations, you might probably use different techniques, or maybe it could be a numerical column can be already in maybe, I think, a string format. So you need to convert that format into a format that you can work with. You can apply operations, mathematical operations on. So something like learning, by the way, that's where data wrangling comes into, learning how to convert a column into from one data type to the other also comes in handy. So you can always do that. So At this particular point, if you're an Afterwork member, pause the video, work on the challenge, and then we can continue. Mode imputation. So mode imputation still almost works the same. The only thing is that you're going to be filling in missing values and replacing the missing values with the most frequent value in that column. The most suitable use case would be when you are working with categorical data. But if you're not working with categorical data, you can still also apply it the same in a numerical column. So that's what we're actually going to see, how we can also do that in a numerical column, but you can also try it for a categorical column. So let's run this. We have age, income, and education. By the way, you can try for education and see what happens. So we define that we want to work with mode imputation by stating this value, mode most frequent. And we applied it to income, so income should be 0. Yeah. All right, so pause the video, work on the challenge, but you could also try to change now for income, for education, and see what how that happens. Pause the video, and once you are good to go, then we can continue to the next one. So we'll continue now to machine learning for missing data. So far we have gotten to learn how to perform basic imputation techniques. Now we're going to learn how to perform a bit of what is called machine learning, using those techniques to come up with a fairly representative value based on already existing, or the records that you already have. So missing values that are influenced majorly by patterns within the data set that you're working with. So that's what we're going to learn. We'll start first of all by learning about the KNN imputation, or KNN imputation. It's called K nearest neighbors imputation. And what this type of imputation does is it considers which of the records are closer or resemble the record that has a missing value, and then it would do an average of the records for, say, the column that is in question. So it would take maybe age and income, maybe for two assuming that let me even just explain it a bit much more clear. Assuming that you have a data set of 100 records, we want to use KNN for imputation. Maybe record 10, and 10 just has a missing value. So if you're using KNN imputation, or K nearest neighbors imputation, we would get this algorithm, or get this model. It would check the entire data set, and it would look for records that resemble the record that has a missing value. It could be, maybe we might want only to look for two. By the way, we usually define how many records actually we want to resemble. So it could be that we want only to specify 2 records and use those for calculating the missing value. So we could decide maybe record 59 and record 82 are the 2 records that resemble the one that has missing value. And what it would do is it would get the values for the columns that are missing in record 10 for records, the ones that I've mentioned, 82 and 50, and it would do some sort of imputation, calculation to come up with a realistic value from those values, and that outcome would be now what would be used for the missing value for the record 10. So you could always just rewind a bit to just get an understanding of what I've talked about. But yeah, so that's generally how KNN usually does. It just looks at other records within a data set that closely resemble the records or record that has missing values, and it calculates the new values based on those other records that resemble those missing records. So Something else to note is that when we are working with the KNN imputer, we define how many records we want to use that resemble the records with the missing value. So here we usually say k neighbors n neighbors is 2, or we can just pass that as just 2. You can even define 10 or 5, but has to be a number smaller than, of course, your data set. So so we, let's say, check for the missing values. We see that we have age, income, and education. So we will only work with age and income. These are numerical values, numerical variables. So we instantiate our imputer. So here we are importing this class, KNN imputer, and then we are getting an object of it, or creating an object of that class, which is just what we did also for the simple imputer earlier. Then we define that we want to impute the missing values for age and column using the imputer fit transform method. And then it transforms it imputes the missing values based on the strategy that we've talked about that KNN tends to use. And then we update the original data set with the imputed values, and then we check for missing values. And in our case, we only have one for education, in which we can later onwards use, let's say now, a mean or mode imputation, considering that education would be categorical. If you can always just check df.head to just inspect the values, type of values that we have for, like you can see, education, it's a categorical variable, so you can always use mode for that. And that's generally it. That's boom. But again, well, as best practice, once you've finished identifying the missing values, you could always check the effect of that technique you did has on the distribution, or even just other aspects of, or statistical aspects, or this, could be the skewness or the median. Just see what effect the technique that you applied has on the overall data set. And you could decide to calculate maybe the statistical measures before imputation and statistical measures after imputation. And you would actually tend to be looking for that imputation methods that has the least significant effect on the difference in terms of those statistical measures that you're looking for. Because I mean, new records should not heavily impact. But again, in some situations, there could be anomalies. So that still doesn't count it as still, like, like the best missing value that you that you might have if you think that maybe there's little difference between the new missing value affecting the distribution of the data set. It could be that actually the missing value that you're imputing was an outlier, which is a genuine outlier. So, and someone maybe somewhere might have decided to remove it because they thought it was an anomaly, but it wasn't really. So it's still something that you have to take note. Okay. That's the first machine learning technique that we've learned. KNN is a machine learning technique. So let's learn how to work with a different machine learning algorithm. So we'll first of all check our missing values for this particular case. And we are going to now use what is called decision trees. When it comes to working with decision trees, so decision trees is a machine learning method that we can use to predict values based on a data set, more like even KNN. The other machine learning algorithms that we can use, that is something that if you want to learn a whole lot more, you could always consider maybe a workshop that's focused on machine learning. Could be regression, classification, ensemble learning, etc. So But for ease of learning, we're going to learn about just a few, just three. So decision tree algorithm tends to work by predicting, still almost not really so using the same approach as KNN, but this algorithm usually splits a data set and into a structure that looks more like a hierarchical or a tree, and it tends to learn from the entire structure of the data set, and as a result be able to make predictions. I won't go back into the technicalities of it. One might even have a whole workshop on just decision tree imputation, or decision tree and understanding it. But just learning that that decision trees are usually, or this technique is usually much more accurate than KNN, or than many of the models that we might use, machine learning techniques that we might use, simply because they're what are called, it's this is usually what is called overfitting, which I won't go much into. It allows that you can be able to so this technique can predict values which are newer and are far much more different from the data set that it has learned from than any other model. So if it gets new values that do not necessarily resemble what it got to learn from the existing or the historical data, this algorithm tends to do well, as opposed to other algorithms. So let's get to learn about how to work with this technique. And an algorithm, you can think of it as just a complex mathematical formula, or just function that allows us to give, that we can give an input and it gives us an output. So yeah, but generally, let's see how we can work with the decision tree regressor. So in our case, by the way, decision tree, they usually come into two, even the KNN imputer, but the decision tree algorithms usually come in twofold. So there's a regressor. So if we are working with numerical values, we'd use a regressor. If we're working with classification value, we would use a classifier. So it would be decision tree classifier. So let's see how we can be able to work with this regressor. We just want to impute the missing values. So the different steps, please bear with us. Some of them are a bit more complex. I would just really just direct you to those Python fundamentals as well as data wrangling workshops before you even go into this. But yeah, so we first of all identify the numerical values with missing values. So that's what we do, and we store those columns in this particular variable. So this is just a way of just getting those numerical values. You can use a different method. This is just one of the ways that you could be able to get those columns. You can just get them individually or select them differently. But this is just a quicker way, assuming you had multiple column names that are numerical in nature. Then we drop those non-numeric columns. We just drop them so that we drop them. Technically, we want to just work with the numeric column. So here we're actually doing the same thing. We're dropping the non-numeric so that we have numeric in this particular variable. Then we identify those numeric variables with missing values. That's what we do here. And we save them here. So numeric missing values, missing columns. And that's what we're going to apply. That's what we're going to look for. We're going to estimate the new missing, the representative values that will replace those missing values for. So we then split the data into complete and incomplete data sets. So as part of machine learning, we tend to learn that when it comes to training, maybe a model, which is basically the algorithm, the machine learning or the program that's going to be making predictions, we tend to split data and then train it afterwards. So yeah, so we'll get also to see how we can do that. So we just split the data into complete and incomplete data sets. So data sets without missing values, and data sets with just missing values. And then we instantiate our algorithm, that's a decision tree regressor, based from here. And then here we decide to we decide to train now the decision tree model, which hasn't been trained on any data. That's what we are doing actually in this line. We are training it based on the complete data that we have here, but we are dropping the numeric missing calls in that particular data set. And we're also training it against also, we're training it to be able to predict the values of Y. So for each and every data set, so we have a data set that has X values, so it has multiple variables and Y to be able to predict now the complete numerical values. So we train the model, then we use it to predict the missing values here, and then we fill in missing values, and then we print out, we check for missing values within our data set. Again, here we are using a method that we would normally use when it comes to selection of data, that's lock. So if you're also familiar, you're not really so much familiar with this, you can always visit the data filtering with Python course that we have. So let's run this, and we should be able to see that we don't have any missing values so far. So you can just quickly just go through, or not quickly, just slowly pause the video, just go through the entire content slowly by slowly, understanding what's happening. And also we've provided some explanation that provides you with an idea of what's happening. So this just works for numerical data, but if you wanted maybe to do the same maybe for other types of data, you could always do the same. Or alternatively, you could decide to convert the categorical columns that you have into numeric columns, and then use those for that. But for categorical columns, assuming there are categorical columns that you would want to predict, or the missing values that you're working with, let's say the missing column is a categorical one in nature, maybe gender, then you would have to use a decision tree regressor, and you would work with now the decision tree, not classifier, sorry, classifying the situation. But this method is usually an advanced one. That's only if the basic methods do not significantly help you to get to the solution that you want. So this is one method. There's another method, another powerful method, far much more powerful than the decision tree machine learning technique. And this allows us to take into account of multiple, they're called Bayes models. So you can have multiple decision trees and be able to use them to come up with a far much more accurate value that is representative of the missing value. So let's we'll import just the necessary libraries for that. But before we do that, you see there's an error somewhere here. We are getting oh, we can remove. Let me see. We're getting an error since it is. Okay, so I think I'll have to look into this. Okay, so I think this has we would have to import. I think we have to do this experimental iterative. I think we have to put this in here. I think this should work. I'll add this into the notebook later, so you don't have to worry about it. So once we have run this, we can see that we have missing values. That was just an error based on how you import, how these classes have been organized in the libraries. So sometimes they update them. So, but we are good to go. So yeah, so we check for missing values. We have weight, which is missing. So how do we use the gradient boosting imputer? This is an easier way, by the way, than what we did here. But you could also still do the same thing. You get maybe a decision tree regressor, and you pass it here. So yeah, so we initialize the gradient boosting imputer using the iterative imputer. So iterative imputer is what we have imputed, we've gotten here. And then we set the estimator, which is the model that we want HIST gradient boosting regressor, which is what we have here. But you can still use just normal HIST, normal gradient boosting regressor if we want, but that takes a bit of some time but it's not that significant. It's quite little. So we define our imputer, which will be the gradient boosting HIST gradient boosting regressor. We define the non-numeric columns, the one that we want to work with, and then we check for missing values. We actually impute the missing values with the realistic values that have been as a result of this estimator of this machine learning model, and then we impute the missing values and we convert back to a data frame. We check the missing values there. And that's what we have for only the imputed DF. But if you want to replace the imputed DF again, you can use this technique that we did here. So this is what we did, but you could decide to put them back if you have an idea of what columns that you're working with. But yeah, so for the columns that we had missing values, we had in weight, yes, weight is the one that we had. So it's 0, but again, you can combine now this imputed DF with now the original DF column that didn't have, and you're good to go. All right, last but not least, we are going to just learn. You can pause the video. Even, by the way, you could also, just for extra practice, consider other data sets that we have had, we have worked with, and then you could decide to maybe perform this operation. And you can also try just different machine learning algorithms and see what happens. The last thing that we're going to do is just evaluate the effect of handling missing data. So I'd mentioned to you sometimes when we are performing imputation, we would want to ensure that the new values that we introduce in place of the missing values do not significantly impact our analysis. So how can we be able to do that? Our distribution or the structure of our data set. So let's first of all check for missing values. We can check for missing values as such. Here I see we have a missing library, so I'll just import it just here. Import numpy as np. Then we select the numerical columns. We can select the way we've done here. We can also select them the way we've done here. You know, there are many options you have. Then we create a copy of the original data, maybe for comparison later, just printing out. So we see this is what we have initially. Then we impute the missing values with a mean. Here we're just doing it with a mean and also comparing what that has in terms of the difference with the statistical properties initially. So we replace the numeric columns in the original data frame. So here we're just imputing with a mean. I'll just click on this. I'll go through this quickly. And we have this, and we just want to check the effect of the just statistical properties. So initially we had our data set DF original and the imputed one. So we want to check the statistical properties and the differences as a result of just imputation. And yeah, we can now compare. Let's say, for example, after imputation, which missing column? Age. After imputation, age has a mean of 35.75, 35.77. Standard deviation, it's a bit slightly bigger, the 25th percentile, etc. We can also check for other columns that we've imputed on, and we can make that deduction and consider maybe other better imputation methods that have little significance or little difference between the two. So yeah, so that's it in terms of this workshop. I hope you were able to learn a lot. You can pause the video by the way and work on the challenge, and also consider becoming an Afterwork member because you are able to work on so many challenges, and we have these workshops often. The next steps, we would highly recommend that you consider a project in handling missing data that we've provided in our website. And we hope that you're going to learn other workshops still in relation to healthcare. All the best in your learning journey.